Hi everyone, my name is Kelvin Raymond Muniz from Harvard University. Today we're going to talk about the engine room of the digestive system, the small intestine. As a future physiotherapist, you might wonder why does this matter to us and why is it well about to be studied in school? It's all about energy. Our patients need proper nutrients to recover, heal tissue, and power their muscles. So let's see how our body actually extracts that fuel. Anatomy and histology. Think about the small intestine as a long, highly specialized tunnel. It's about 6 meters long. We'll break it through into three parts, which are the duodenum, jejunum, and ileum. Duodenum as the mixing bowel, jejunum where the real works happen, the primary engine of nutrients absorption. And the last one, ileum, is the longest part specialized for B12 and bile salt recycling. The intestinal wall. The intestinal wall, we have three walls. We have the mucosa, which is the inner lining for the absorption. We have submucosa, the connective tissue for the vessel, and muscularis, two smooth muscle layers, the serosa, protective outer membrane. Mastery surface area. Mastery of surface area. The small intestine increases its internal surface around 600 folds via the three modification, which are the circular folds, villi, microvilli. This villi is a finger-like projection of the mucus. Here, as you can see. Microvilli, the brush border on the individual interocyte. The circular folds, Pilcae circularis, slow down the chyme. What now let's look at this scope. What the physiological function, which have digestion, motility, and nutrients uptake. Motility patterns. We have two. We have segmentation and peristalsis, which this peristalsis occurs like contraction that propel food forward, occurs after most absorption is complete. Migrating motor complex. Segmentation. This is a localized contraction that makes chyme with digestive juice essential for ensuring nutrients contact the mucosa. Okay, we're going to the digestive part. We have nutrient, enzyme, and end product. The enzyme, we have amylase, maltase, lactase, which work in carbohydrates and produce monosaccharide, trypsin, peptides, which work in protein and produce amino acid, lipids and bile salts, which work in fats to produce fatty acid, and glycerol, nucleases, which work on nucleic acid to produce pentose sugar and bases. Also, the bile from the liver is vital for the emulsification. What is emulsification? Emulsification is the breaking down of small droplets of big fat droplets into small droplets in the liver. Mechanism of absorption. Absorption occurs the enterocyte membrane via passive diffusion for water and some lipids, active transport for glucose, amino acid, and electrolytes, facilitated diffusion, which fructose transport. Physiotherapy perspective. Here is where our scope is. The post-OP, mobility, nutrition status, and referred pain. Nutrition status. Poor absorption leads to muscle wasting and weakness, directly impacting a patient with rehab potential. Referred pain. Dysfunction in the small bowel can cause referred pain to the mid-back, T10 to L1 regions. Post-OP mobility. Early mobilization, walking, stimulate the intestinal motility and prevent post-surgical ileus. So these are the takeaways. We have anatomy. In anatomy of small intestine is comprised of three parts: duodenum, jejunum, and ileum, about 6 meter total. Structure: villi and microvilli. They create a massive surface area for uptake. Motility: segmentation mixes and peristalsis move. Physiology. This site of 90% of digestion, and nutrients absorption, as well see those enzymes there and work in different food like carbohydrates, protein, lipid, fats. Okay, physiotherapy link vital for energy during rehab and post-surgical recovery. Thank you. These are my references and these are my image sources and the reference. Thank you so much.